we are gonna do a question which is a vector a vector a vector of length L. So when we are talking about length, we're talking about the magnitude is turned through an angle theta about its tail at origin, full stop. What is the change in position vector of its head So the question that we have been given is, suppose there is a length L, it is turned about an angle of theta about its tail at the origin. So what is the change in position vector of its head? So to understand this, it will be much more better if we do it by a picture, right? And doing it by a picture will be much more better. So what this is talking about is to find the change in position vector of its head. So let's just draw the figure. Let's say this is our vectors, right? So let's make this white, and let's say this vector has a length of L, so the length is gonna be L, right? Now we want to rotate this vector such that, so let's rotate this by an angle theta. So I'm just gonna make this, and I'm gonna change its color slightly so that you know that this is still the same vector, just a little bit different. And you might not see the slight color change, but there is a slight color change. Okay, so it's rotated by an angle of theta. Now I need to find the change. So to find a change of in position vector of its head, so this is the head of the vector, right? So this portion, so this is the head, so this is the head of the vector, right? Since this is the head, we need to find the change in head. So we need to find from here to here what is this change, and let's make this bigger. So we need to find this change. So this is the change, and let's say the change is represented by vectors C. Let's say this is vector C. Then it's gonna be about let's say this is vector 1 and this is vector 2, and just for the sake, so it's going to be vector 2 minus vector 1. So this vector is that vector. You can also understand this by thinking of a triangular. So if you think about the triangular, it says that two vectors, so let's take this white vector and this yellow vector, which are in same order, then the third side in opposite order will give the resultant. So this is basically so vector 2 will be vector C plus vector 1, right? So that's why this is this, and so we are moving it left and right to make it much more workable for us. So I think this is much more clear why this is this. So we need to find vector 2 minus vector 1, and to find vector 2 and vector 1 we must use the vector subtraction, and I think you know the formula, so we are just going to use the formula. So here change in position vector of its head is, so let's say the change in position is vector C, so we just need to find the magnitude. So to find the magnitude, it's gonna be this, and there will be a square root L square plus L square, since it's going to be a square plus b square minus 2ab cos theta, right? So we have this, let's put this right over here like this, and now let's just do some calculations. So this is gonna be 2l square minus 2l square cos theta and we can take 2l square common. So if we do that, so if we take 2l square common, we have 1 minus cos theta, and 1 minus cos theta turns out to be a formula for it's a formula for let's write that, square root, so 2l square, and this is actually 2 sine theta by 2 square, so it's sine square theta by 2. So this is the formula of this, so this is equal to that, and let's keep the square root. Now if you do some quick math, you will see that so let's just do this in another page. It's gonna be square root 4, since it's gonna be 2 times 2, 4 l square, or let's write this as 2 square l square sine square theta by 2. So this is the equation, or this is the thing that we have. Now we just need to simply just take out the square root. So to remove the square root, we are gonna do this. Now it's gonna be 2l sine theta by 2. So this is gonna be the magnitude, right? So this is actually it for the question. But a question that you might have is, why did not we find the angle of this vector? Because when we are talking about the change of this position vector, we don't need the angle, we just need the change. So the change we are going to talk about is in terms of length or magnitude, and this is the length or magnitude. If we had the value of L or theta, you would obviously have to put it over here to find the value of this, but you don't need to find the angle between any of these vectors. And a quick thing that I think you should know is, I forgot to write this one thing. This is at 0, 0. So this is also at origin. Since this is at origin, vector b1 and vector v2 are position vector as well, and position vector are represented by generally vector r with some subscript, but let's not think about that. I'm just saying that this is also a position vector, this is also a position vector, and the change in the head is going to be this. Also, if there is a question about what is the change in position vector of its tail, it's going to be 0, since the tail is not moving at all. I think that's pretty clear. So this is going to be it for today's video. On the next video, we are going to talk about another question. So till then, bye bye.